Good morning, my dear students. So, in this PPT, I'm going to solve some numerical problems on primary balancing. Okay. So, in the last class, we solved about the secondary balancing and V type of engine also. Okay. So now this class, I am going to solve two numerical problems on primary balancing. Okay. So, in primary balancing, normally when we are not going to construct any force polygon and couple polygon diagram. So, just we have analyze how you have to realize or you have to remember the list of formulas. So, just you read the question and substitute, you are going to get the final answer. Okay, so here the question is given, that is the first problem. The following data are referred to a single cylinder engine. So otherwise primary balancing are related to single engine. Okay, so the following data are referred to a single cylinder engine, that is the speed is given 250 rpm, stroke length is given, that is 350 mm, and mass of reciprocating parts are given, that is 60 kg, and the mass of rotating parts, that is revolving parts at 175 mm radius is given, that is 175 mm radius and is the 40 kg. Okay, so that is mass is given. If the 2 by 3rd of the reciprocating parts and all the rotating parts are to be in balance 1, then you need to calculate or to find the balancing masses required at 400 mm radius. Second one, they asking what residual unbalanced force when the crank has rotated 60 degree from the TDC, that is top dead center. Okay, so need to calculate these two. Okay, so they given one IC engine, that is a reciprocating engine. From that there is you need to calculate the balancing masses required at 400 mm radius. Okay, so note down all the given data here. Speed is given, that is 250 rpm. R is equal to what? The connecting rod radius always, that is a stroke divided by 2, that is a stroke length by 2, that is 350 by 2. You are going to get 175 mm, that you convert into meter, that is 0.175 meter. Okay, the mass of given, that is a 40 kg at 175 mm radius. Okay, mass 60 is given, that mass at the radius they not given. Okay, that you need to find. Okay, C is equal to given, that is a 2 by 2/3. Okay, so here the given if the 2/3 of the reciprocating parts. Okay, so that is denoted by C, that given 2/3. Okay, so B is given 400 mm, that is 0.4, that is a 400 mm 0.4 m. Okay, theta is given, that is 60 degree. Okay, so if before solving the primary balancing, I given the list of symbol and units and formulas. Okay, in the notes we have to remember that. Okay, so here the balancing mass is equal to what? MB, that is balancing of mass B is equal to C into M plus m1 into the that is into r. Okay, so B is equal to, that is 0.4 is given, that is a width. Okay, so B is equal to 0.4 divided by cent, that is a ratio is given 2 by 3rd into 60 plus mass is given 40, so into 0.17 r, that is you are going to get the balancing mass B is equal to 35 kg. Okay, second one is a residual unbalanced force. So residual unbalanced force formula we have already be derived in the general, that is a derivations, that is m into omega square r square root of 1 minus c whole square cos square theta plus c square sin square theta. Okay, so substitute all the values here, so you are going to get 4324.6 newton, that is 4324.6. Okay, so this is about the residual unbalanced forces. Okay, so if you want to solve this type of problems, you have to remember the formulas. If you if you are not remembering the formulas, then you cannot solve the problems. Okay, so this is about the first problem, very simple. Okay, balancing masses, the residual unbalanced forces. Okay, so second one, I am going to tell you about the second type of problem. So here also they given the following data or given data related to the single cylinder reciprocating engine, that is the mass of reciprocating parts is equal to 40 kg, and the mass of rotating parts, that is revolving parts, 30 kg at 180 mm radius, and the speed is given 150 rpm, and the stroke is given 350. Okay, so if the 60% of the reciprocating parts and all the revolving parts are to be a balance, so you need to calculate or to determine what the first one they are asking, the balancing masses required at a radius of 320 mm, and the unbalanced forces when the crank has turned 45 degree from the TDC. Okay, so normally if you take the any IC engine, there is a rotation of piston takes place. They get the TDC, BDC, BDC, TDC. Okay, so up to 720 degree they may take. Okay, to complete one cycle. Okay, so from this calculate, note down all the given data, that is mass is given, that is 40 kg, capital M1 is given, that 30 kg, that you need to calculate here they given. Okay, 30 degree, that is mass of rotating parts is m1, mass of reciprocating parts is 40 kg. Okay, rotating m1 stands for rotating, that is stationary. Okay, so r is given 180 mm, that is equal to 0.180 m radius of the rotating mass or revolving mass. Okay, so n is given 150 rpm, that is speed is given. So we have the formula, that is r is equal to r, radius is equal to stroke by 2, that is 250 by 2, you are going to get 175, that is equal to 0.175 meter. Okay, so here the C is given 60 percentage. Okay, if you convert that divided by 100, you are going to get C is equal to, here this side left hand side, okay, C is equal to 0.6. Okay, B is equal to, that is 320 mm, they given is equal to 0.32 meter. Okay, they given 320 here. Okay, so that is radius. Okay, the balance mass required at a radius of 320 mm. Okay, balancing of radius is 320 mm they given. Again, if you convert that is into meter, that is okay. Theta is also given 45 degree. Okay, so it has turned 45 angle from TDC. Okay, so BDC to TDC, TDC to BDC, they given 45 degree. Okay, so again formula, same formula you need to apply here also. That is the balancing mass BB is equal to what? The balancing masses B, C into MR, that is C into M into R plus M in 1 into R1. Okay, substitute all the values. B is equal to, B is given 0.32 is equal to 0.6 into 40 into 0.175 plus 30 into 0.18. You are going to get the balancing mass B is equal to 30 kg. Okay, similarly second you need to calculate here the resultant unbalanced force. Okay, so resultant unbalanced force formula is R into U into F. Okay, so M, that is a mass, that is a this mass we have to take here, that is M. M is a reciprocating part mass. Okay, this M is a capital M is a reciprocating mass, M1 is rotating. Okay, that is rotated. Okay, so here the resultant unbalanced force is equal to M into omega square into R square root of 1 minus C whole square cos square theta plus E square sin square theta. Okay, so substitute all these values. Okay, you are going to get what? This 40 into omega is equal to 2 pi n by 60. Okay, where n is 150 they given, 60 whole square into 0.175 square root of that C, same 1 minus 0.6 whole square cos square 45. Okay, plus 0.6 whole square sin square 45. You are going to get the resultant unbalanced force by using calculator. If you substitute all the values, so you are going to get what? Result 88.7 Newton. Okay, so this is about the problems on primary balancing. Okay, so I hope you understand this. In primary balancing you have to remember the two formulas, that is the balancing of mass B, that is B, capital B into small v is equal to C into M into R plus M1 R1. Second, resultant unbalanced force is equal to that square. Okay, so M1, that is what? M omega square R, where omega square is equal to, that is angular speed, that is 2 pi n by 60 square root of 1 minus A whole square cos square theta plus E square sin square theta. Okay, these two formulas you have to remember and to solve the problems on primary balancing. Okay, so I hope you understand this type of problems. Okay, so balancing of reciprocating masses, that is the second topic. So in that I solved the problems on primary balancing. So again, so problems on secondary balancing is little difficult. So there we need to construct the all the diagrams. Okay, so this primary problems on primary balancing are very simple. Just you have to remember. Okay, that is much not required to graph all those things. But whereas in while constructing the secondary, that is problems on secondary balancing, that is related to inline engine, you have to construct the force polygon, coupled polygon, unbalanced primary and unbalanced force polygon, all those things. Okay, so now I'm going to stop this. I hope you understand these problems. Okay, so thank you very much.